Welcome, everyone, to the Xojo 2024 Pi Day webinar. I'm Paul Lefebvre, one of the software engineers here at Xojo, and I'm your host today. I won't be doing too much talking. We have guests for that, but let's just jump right in. Thank you for joining us. So it's Pi Day. Happy Pi Day, everyone. Pi Day is one of my favorite nerdy days of the year. And I invite you to join me on the nerd side. People that work with me know that I'm a huge Star Wars and Darth Vader fan, and I couldn't resist making a meme. But Pi Day is mostly about the number pi, which is a cool number. But today we are going to be kind of taking a little spin on that and talking about the Raspberry Pi, which of course is related to pi itself in name at least. And we have four presenters here that are going to talk a little bit about some cool things that they've made for the Raspberry Pi using Xojo. So let's jump right in. First up, we have Tim Dietrich. And Tim is a longtime Xojo user and a NetSuite software developer. And Tim is going to be talking to us about how he uses Xojo with Raspberry Pi and something called Phidgets, which I will let him explain. Tim, the floor is yours. I think you can just share screen and kind of steal it from me.
Yeah, I think you have to.
I have to stop first.
Yeah, I think so.
Oh, that'll be tricky. All
All
right,
right.
try it now.
Yeah, it goes. All right. I think you can see that, right?
Yes.
Okay. All right. So yeah, so this is the Xojo Pi developer panel, and as Paul said, I'm a custom software developer. I focus on developing apps for businesses that are running on NetSuite, and of course, that usually means developing them in Xojo. And I think I said this to Jeff when we did a webinar last month that like this is the 10th year I've been using Xojo, and I can't believe it. But anyway, and it seems like just yesterday I started playing around with it. You can learn more about me on my website, and there's the URL. And I'm actually going to show two applications today. They're going to go pretty quickly through them. The first one is basically a web service or web API that uses something called Phidgets, and I'll explain what they are in just a minute. So basically what the web service does is it provides the current temperature and the humidity of the room that, in this case, the web service is running on a Raspberry Pi, and you make a request to the web service and it gives you back information about kind of the environment of the room. It's a Xojo Web 2.0 app that I developed, and it's running on a Raspberry Pi 3. I'm using the Bullseye version of Raspbian. So if you're a Raspberry Pi user, that might make sense to you. It's just the version of the operating system. And what Phidgets are essentially sensors. Let me show you what that looks like real quick. I have a web page here. This is where you go to phidgets.com. You can see all the different sensors and things that are available to you. But this is what it kind of looks like. Basically, I have a USB. This is an image I got off of their site, by the way. But there's a USB cable that's connected to the Raspberry Pi, and it attaches to this Phidget hub. And then what hangs off of the hub is, in this case, a humidity fidget. I have a second one that hangs off of it that gives me the temperature. So I first learned about Phidgets at XDC in Nashville, and it was something that Christian from MBS talked a little bit about, and it kind of piqued my curiosity. And as soon as I got back, I ordered some of these things and started experimenting with them. I actually have a real world need for them, so that's why I was so curious. So going back to the slide, I'm using the MBS Phidgets plugin to basically read the data coming off of those Phidgets. So let me show you just real quickly what that all looks like. So this is actually the data coming back. I have the Raspberry Pi 3 running locally here in my office. And if I just reload the page, you'll see it'll come back and tell me the date and the time. I've got an array of the sensors that I've got connected to it. One is temperature, one is humidity. And then you can see some information about the sensor itself. The most important things coming back are the values that it's reading off of the sensor. So I've got the temperature in degrees Celsius and in Fahrenheit, and then the humidity level is there as well. So that's what the response looks like, and it's very fast. If I reload the page, you see it's super fast. So going back to, I'm going to show you just a second, like here's what the app looks like. It's really not much to it. It's a Xojo Web 2.0 project. When it opens up, it does some initialization of the plugins and the Phidgets. One of the things I learned about the Phidgets is they sometimes can take a second to open up and become readable. So I've got to pause in there to do all that. But if you just look at that code real quickly, you see that I've got some code that branches based on the platform that the app is running on. It'll load the correct Phidget library, which you get from phidgets.com. And they load differently based on the operating system, of course. So I'm not going to go into all the details of this, but basically I'm initializing the Phidgets. And then when a request comes in, I'm just handling it with handle URL. If you've been on any of the webinars in the past, I think Jeff did one, I think it was last year, about how to use Xojo to build web APIs and web services. The handle URL event handler is really the trick to all that. And so that's where a lot of like how this works, is implemented. So I get the request and I just basically build up a response, read the values coming off of the sensors. I've got some methods that do that. They check to see if the sensor is actually attached. So if the one accidentally becomes detached, the app won't crash or anything like that. And again, the response looks something like this. So pretty straightforward. It was a lot of fun to build this. The first version of it that I built was actually a desktop app that just directly read the sensors and showed them like spinning every second. It was updating the UI every second. So that's the first app that I wanted to show. And the second app is an app that I built to monitor the values coming off of a web API. And so basically it's a JavaScript-based app, and I'll explain why I'm showing you a JavaScript app here on a Xojo webinar in a second. But it's a JavaScript application that's interpreted by something called allo.js, which I'll explain in just a minute. The app is actually running on another Raspberry Pi that I have here. It could run on the same one if you wanted it to, as the web API. And it's using a newer version of the operating system. It's called Bookworm. And basically all it does is it loops and just keeps making calls to the web service to say, hey, what's the temperature and the humidity? And it gets the values and shoves them into a CSV file that just keeps appending to it. And just keeps doing that until you tell it to stop. There's a pause that I have in there so that you're not constantly, like every second, making the call. And I've got it kind of cranked up for the demo, which I'll show in a minute. But getting back to that allo.js, what it is it's basically a JavaScript interpreter that lets you run JavaScript applications outside of a web browser. It's cross-platform, runs on Mac OS, Windows, and Linux. And here's why I'm showing it in the Xojo webinar. This is something I've developed in Xojo using the MBS Tools plugin. So it's actually, the guts of it are an embeddable JavaScript engine called Duct Tape. And I'm going to be releasing this soon. It's going to be closed source, but you can use it for free. But I think what's neat about it is this is a JavaScript interpreter that was developed with Xojo, which is kind of cool, I think. And it's running on the Raspberry Pi. So let me show you what that looks like. And to show you that, I'm going to go here. So this is something called VNC Viewer. it's letting me kind of peek over at the Raspberry Pi. And I've got two essentially terminal windows open here. If I run this, this is how you run the allo, the JavaScript file. You just tell it, hey, here's the path to the file that you want to run. You know, it's probably kind of hard to see that. I don't think I have a way to zoom it in. As you can see, it's now running, it's getting data from that web API. And if I go to the other window, I have the log, it's a CSV file. And if you watch it, it'll just tail the log. So it'll always show you the last few lines that were written to it. So there it goes. And you can see, if you can see the numbers that are shown there, it's the date and the time, and then the temperature and the humidity. So let me stop those. Jumping back over to my slide. And so the other thing I wanted to show you is here's what that file, the JavaScript file actually looks like. If you're familiar with JavaScript, this should probably look pretty familiar to you. It's the best way for me to describe what allo is. If you're familiar with Node, it's kind of the same idea, but not really. Only similar in that you can just write JavaScript and run it wherever you want. So that's the idea behind it. I'm not going to go through every line of this, but if you're familiar with JavaScript, it should mostly look familiar to you. You know, I think the real guts of this application are that you can use pretty much anything that curl can do. So you can see I'm making a call to curl and getting the response back, and then writing the file out to both the display and to the CSV file. It pauses for a few, usually a few minutes. In this case, I have it cranked up so you can see the values updating quickly. But that's really all it is. So, and this again is running on that Raspberry Pi. So I think that's it. If there's any interest in the Xojo project that I showed, that the web API that connects to the Phidgets, let me know. I can make it available sometime next week. And the allo.js tool that I showed you, I'm going to hopefully have that ready to go later this month. I've been saying that for months, so don't hold me to it. And that's it. Paul, are there any questions or?
All right, thanks, Tim. No questions yet, and that does prompt me to remind everyone that if you do have questions, use the Q&A button at the bottom of your Zoom viewer, and you can type your questions in there. And at the end, after everyone has presented, we'll review the questions and ask those. So let me switch back here.
Tim, was there any UI for that first app? You showed the code, but you didn't show the UI.
For the web app?
Yeah, the original web app.
Yeah, so I mean that when I was going to the browser and refreshing, it was just
Oh, that
making
was it. You're just putting. Okay, got it.
Yeah, all it's doing is returning that JSON sort of text back to the caller. So yeah, it's really simple, really fast, and it doesn't crash ever. So I've had it running for months. It's pretty neat.
That's always a plus.
Yeah.
All right, next up is Michael Smith. And Michael is, and he's got a longer intro here, so I might just summarize that. And Michael is an entrepreneur and social media influencer focused on technology and robotics. And he has a prepared video here, which we might all be very wowed with the production quality. So let me just get that rolling.
Computers controlling motors. That's pretty much the thing for me. My name is Michael Smith, and I guess I'm a YouTuber. My channel is Nerdtronic. Not Nerdrotic. That's a different channel. Mine is Nerdtronic. My video about Roybot the painting robot is why I'm here today, because I use the Pi as a computer controlling these motors and I wrote the software in Xojo. But in case you don't know, I built a huge robot that painted this Liechtenstein-style painting. First, let me tell you a little bit about myself. My background is mainly in two areas. One is software development. I won't tell you how long ago I wrote my first application, but in this century, I made an iOS app called Big Bad Sudoku Book and another one called Math Speed Drill. These have each been downloaded over 1 million times. My other background is in television and movie production. I was the visual effects supervisor on the cult movie Bubba Hotep. I also edited several primetime reality TV shows and was nominated for an Emmy. And I worked at another YouTube channel and did 5-minute animated videos for them and have about 200 million downloads there. At Nerdtronic, I try to build cool projects where I can mix design, engineering, programming, and hopefully or occasionally art. Let me tell you about some of the projects I've worked on over the last couple of years, some which made it into videos on my channel and some that didn't. The dog door. I hacked an electronic dog door so I could control it with Arduino. I added motion sensors and RFID so that a small lightweight tag can let my small dog in the door. The robot finger. I really liked this project, but the video didn't do very well. The goal was to create an Inspector Gadget type robot that would pop out of a cup holder in my car and push a button. It used cheap servos and in the end didn't have enough torque to actually push the button in. I made a lot of mistakes on that one, but I learned a lot. Bulge Buster. This was a 3D printing helper app that was developed using Xojo. It ran on Mac and Windows and Pi. We stopped support for it because the 3D printer software company locked up the file format. Some of those projects used Arduino, but for the painting robot, I wanted to use the Raspberry Pi. Mainly because the Arduino was a little underpowered to control the smart motors and handle all the math for that. So, the smart motors. When I saw these motors, I really wanted to get my hands on them and play around with them. The ones I used in my project are from my actuator. These are like the motors that are in the Boston Dynamics robot dog. They're different than a stepper motor. They have onboard controllers and encoders, so you can just tell it to go to a specific angle or rotation. You can control speed, acceleration, torque, or position. The communication to this motor is CAN bus, and I use a serial to CAN bus converter. I send data packets to the motor and then listen for ones coming back. So here's an example of a packet sent to the motor. This one is motor speed control. So it has a motor ID, then a command byte, which is speed control, and then the data packet, which for this command includes a 32-bit speed value. Then the motor will send back a packet to say, hey, I got it and I'm doing it, but I pretty much ignore those. I'll show you some code. Here's the method that draws the path. It's a big state engine because there are so many steps to drawing a shape. There's a timer that moves these steps along. But let's see, it updates the on-screen info, then it gets the path data for this shape, then I ask the motors where the printhead is right now. Then we have to wait for both motors to send back that data. And if we never get it, we have to ask them for it again and report the error. Then we look at the beginning and end of the shape to see which one is closer. If the end is closer, we start there and draw the shape backwards. Next, we have to move the motor to that starting point. For this type of move, I do an absolute move to an exact position. Then we have to ask the motors where they are again, to verify that they actually got to their destination. Then wait for them to return that info. Again, if it doesn't return, we ask again. And if it returns a position that isn't correct, we have to start over and move the motors again. This error checking was critical because on occasion the motor didn't get the command for some reason, and then it would ruin the painting. Oh, and actually now we're moving the motor to the starting point. Before it was moving to the offset point. This is a whole other discussion, but it has to do with correcting for backlash in the belt system. Okay, so now it has to verify that both motors are at the starting location. I update the on-screen info one more time, push the pin into the canvas, and then in a tight loop, I draw the shape. Then lift the pin, and then verify that the pin actually did lift. This one could really mess up the painting, so we have to double check that one for sure. It took several weeks for Roybot to complete the painting. But as it was happening, I would notice something, realize I needed to fix some code, tweak it, and then paint some more. Here's my Pi. I have a touch screen and I have this ribbon cable that brings the GPIO pins out so that I can access them easier. I did software limit switches which use the GPIO pins, but actually in practice I don't use those switches. I have switches that cut the power to the motors if they hit the edges, and those are just for safety. So mostly I'm just using this serial port on the GPIO pins to communicate with the motors. But even though I'm not using the GPIO at the moment, I have it set up in Xojo and in the Pi to be able to use it. First is having the PigPIO library. I call it PigPIO, even though I know it's Pi GPIO. Then in software, you can read a pin with pi.gpio read. On the Pi side, there are some steps that I have to do to make sure GPIO is working before running the app. I open the terminal and then do these commands. Sudo kill all pi gpiod, that turns it off. Sudo pi gpiod turns it back on. And I do this just to ensure that it's on. Then I cd to the folder that has the remote debugger app in it. Then I sudo launch the remote debugger so that the Pi app that the debugger uploads will have admin access. This is kind of interesting. I almost never run the app on the Pi directly. I just debug it on the Mac and then it downloads to the Pi. It works great and I love that feature. So why Pi? I'd say mostly because of the price. Even with this touchscreen, it's pretty inexpensive. And being able to access the GPIO pins directly, like I said, I wanted something more powerful than Arduino, and I wanted to have a user interface. I'm just glad I got this Pi before the shortage happened. Why Xojo? It allowed me to build this app with the user interface really quickly. And I'm constantly making changes to the app and the buttons and what they do. I'll make a little test feature and then just assign that to a button. There were some difficulties with making this app. One is that my drawing file format is basically an SVG file. That way I can create the toolpath in Adobe Illustrator and export it to a file that Roybot can read. But it means that when I have a path command that draws a curved line, there are some complexities in getting all the points along that curved line. There's a really hacked way that I did it, which was to call a command line function. And it can't be done as it's drawing because it's just too slow. On the Pi, it takes about 2 seconds for each of those command line calls, so you can't do it while it's drawing. At first, I did it in the Pi app. Before it drew the line, it would make the call to the command line and get all the points along that line. But it would pause for 4 or 5 seconds. That's a lot of waiting around while calculating. So I actually made another app in Xojo to do it on the Mac. It figures out all those points in advance and then saves them back to the SVG file. Then the Pi app just reads those positions from the file. Another complexity is that I don't want multi-threading or other activities taking up computer time while it's drawing. If the pin is down, I need 100% control of the Pi. So each loop is a hard, tight loop because timing has to be perfect. I'm telling the motors to move at a particular speed. Then a few milliseconds later, I tell the motors to move at a new speed. So if suddenly either Xojo or the Pi decide to check the UI, wait for input, or give a CPU time slice to another app, the change your speed command wouldn't be given in time, or maybe not at all, and the printhead would just keep going, possibly until it hit the side of the frame. But the answer to that was to do tight loops. And when I'm in those, the user interface freezes while my loop is drawing the shape. Without the ability to do that, I wouldn't have been able to use the Pi for this project. Other upcoming projects. Well, I modified Roybot so that it no longer is belt driven. And I'll have a video coming out showing those mods, and it'll also be doing a mathematically generated painting. I'm also building a robot arm pretty soon. On that one, I'm going to try to use the Feather M4 CAN module to control the motors, and that would be Arduino, not Pi. And then I have a big project I want to do, which is a larger scale robot. That one is quite the challenge, and so I'm not sure when that'll come out, hopefully by the fall. Well, that's it for me.
All right. Thank you, pre-recorded Michael.
Yes. Yes.
And I will say I liked that video so much that I made arrangements with Michael to get one of those paintings. So I have one hanging in my office right here.
Yeah, I sold about 30 prints of that painting, so.
Yeah.
Excellent.
All right. Next up, if I can get this to see my cursor, there we go. We have Bruno Frechette. And Bruno is a business management grad with a dual mastery in classic programming and a self-taught prowess in the dark arts of object-oriented programming. He has been the co-owner of Nubood since 1993, and they set the vibe with ambience music, keeps you entertained on hold, and dazzles with digital signage. And Bruno is going to be talking a bit about a Pi survival guide, so to speak. So, Bruno, you're up. As soon as I figure out how to stop sharing. There we go.
Okay. So that's desktop number 2. Share. And here we go. All right. Hi, everyone. And I'm going to be talking less about programming and a little more about the Pi itself to ensure if you have an application where you need the Raspberry Pi to be playing 24/7 without interruption and without any intervention, that's what we managed to do. So I'll share what we encountered along the road. So we use the Raspberry Pi as media players for digital signage, and the Pis are installed at our client locations with no inbound access, so no SSH, no remote desktop, and sometimes with very limited outbound access. Some IT departments at the clients will limit the internet access of our Raspberry Pi only to our own server here. And on top of that, most of the time, there's no one around physically on site that will be willing to go to the Pi to do the reset in case of a problem. So we really need to have these Raspberry Pis work all the time, all by themselves, and fend with winds and tides that can come along. One thing that we learned while doing that is that the Raspberry Pis time travel. Oh yes, they do. Actually, when a Pi powers up, it will be at the date and time of the last shutdown. So it's basically in the past. And that's why, the reason why that is that the Pi does not have a separate hardware clock. Now, of course, like most OS and PCs, the Pi will try to sync network time servers when it starts up to set its internal clock correctly. That will cause a leap in time forward for the Raspberry Pi. But what happens when it's isolated? If it does not have access to network time servers, well, it'll remain stuck at the wrong date and time in the past. So obviously, you're going to say, Bruno, it's easy. Add a hardware clock. Right, we tried that. The problem with the hardware clocks is they have a battery. And we found out the hard way that unlike your PC or your Mac, where you don't really think about the little battery button that's in there powering the hardware clock, in the case of the Raspberry Pi, the hardware clocks will last about 1.5 to 2 years. And after that, well, you're left with no clock at all and back to square one. And changing the battery is not an option. So we had to go another way. And our Pis don't have access to the network time most of the time, the network time servers. So we devised our own way to adjust the clock, which, well, actually is quite simple. Is when the Pi connects to our server, we just provide the date and time of the server, and our software adjusts the internal date and time using those values. But the thing to remember is if you have any application that need to perform some actions at specific dates or times, you need to devise a way to know that your internal clock in your Raspberry Pi is correct. In our case, when our software runs, after it has connected to our server and synchronized its clocks, only then are the messages that require playback at specific date or time, only then are they played. Before that, only messages that have no date or time constraint can be played. So that's something to keep in mind when you're designing time-sensitive operations on your application. Now, when you have a Pi in the wild, your worst enemy is power fluctuations. I had a slide originally saying that you need to pay attention to the power supply you buy, the type of SD card and everything. Well, I know that probably you've run into that. So the power outages and current fluctuations are your enemy. They can corrupt some files. They can freeze your Raspberry Pi if they can even corrupt the OS, rendering the Pi unusable. So you're going to say, Bruno, that's easy. Just put a UPS. Well, UPS have batteries too, and batteries don't last forever. So they do require maintenance. They do require batteries being changed. So that's another solution that we could not look into. Our solution da-da-da, is the supercapacitor. So supercapacitors are great little pieces of electronics. They're not batteries. They have an infinite number of charging cycles and they never need replacing. So it's almost magic, but they store very little power. Actually, with the Raspberry Pi, the supercapacitors that we use will keep the Pi running for only a couple of minutes. But that's okay, because the mission that we have for the supercapacitors is not to power the Pi for hours, but to power the Pi just long enough so it can do a smooth shutdown. So the way it works is when the main power is lost, the board will signal the OS through a script, and the script can trigger a graceful shutdown, while the supercapacitors provide very, very precious power so that that shutdown can be completed with the power from the supercapacitors. And that will prevent hard shutdowns that can wreak havoc to your system. As a side effect, they also protect from power fluctuations. So power fluctuations will freeze the OS once in a while. So if you're installing an environment where you have, like, for example, fridges or motors or other items that draw a lot of current, it can affect the power that your Pi receives. So it will protect against those fluctuations as well. What we use is the Juice for Halt board. You have the address there, juiceforhalt.com. It's a great little board. I'm not affiliated with that company at all, but we've been using it for quite a while now, and it just works great. It fits in most casing. It's small, it's nice, and it's a great little board. Now that we've taken care of the Pi being impervious to electrical fluctuations, there's the very, very bad Pi freezing situation. So sometimes the Pi will freeze for reason, it's not your software, of course it's not, but sometimes it will freeze. And you're gonna say, Bruno, the only way to get out of that is to go to the Pi, you just pull the plug and reconnect it, right? Well, yes, but we can't do that. And we found a way to get out of that dreaded frozen Pi situation. It's a little known feature. It's built in every Pi, and it's a hardware watchdog. And the hardware watchdog is great because it has the ability to restart the Pi even if the entire OS is frozen. And it can do its magic because it's in hardware, so it's always there running even if the OS is frozen. So there are pre-made packages that you can install to control it. But if you're like me, you say, hey, I can do better than the rest of the universe, right? So you want to build your own stuff, which we did. And it turned out to be fairly simple. So to start the watchdog, very easy. You just echo a dot to the device driver, which is /dev/watchdog, and boom, your watchdog has started. In fact, if you only do that after 15 seconds, your Raspberry Pi will reboot. What? Wait, what's happening? Oh, it's because once it's activated, the watchdog needs to what's called a heartbeat. So it's a signal to know that the OS is still running. And if it gets no heartbeat for 15 seconds, well, it's time for a reboot. So you're going to say, Bruno, how do I send that heartbeat signal? Very easy. You just send the same command. So the same dot to the same device driver every other second or every few seconds. So you keep the hardware watchdog in the know that the OS is running correctly. So we have selected a 5-second interval. It gives us a little bit of leeway in case the system is slower. So make sure that the hardware watchdog does receive the heartbeat. When you want to stop the watchdog, very easy. Echo a capital V to that same device driver, and that's it. Fido goes back to sleep, and everything is cool. So our implementation actually involves simply two scripts. One script that will loop infinitely, sleeps 5 seconds, echoes that little dot to the device driver, and a second script, which is the stop script, which echoes the V to the device driver. We wrap that up in a systemd service file that gets started automatically at startup, and there you go. You have your trusty watchdog watching over your system freezes. So that's the major things that we put together to get the Pi running. And with that, it's time to say bye-bye. All right, it's a lousy pun. I'm a French-speaking guy, so that's all I came up with.
Thank you, Bruno. That was a wonderful pun. I loved it.
Thank you.
Bruno, maybe I missed something, but how does when you're set up, how does the Pi know that it's lost power and needs to use the other board to do the smooth shutdown?
Well, the supercapacitor board takes care of that. So the power is actually not connected to the Pi anymore. It's connected to a connector on the supercapacitor board.
Ah,
And the board, when it loses power, continues powering the Pi through the GPIO pins. And so the Pi does not know it's lost power until it receives a signal from the board.
cool. Thanks.
Yep.
All right. Last, we have, I'm sure I'm going to mispronounce this, but Marius Dieter Noetzel is going to be talking to us today. And I don't have a lot to say about that. I haven't seen his stuff, but I hear it's something related to juice. Hopefully I'm right. Marius, you're up.
Yes, I'm here.
All right.
Okay. Yeah, we will do some juice today. You see me?
Not yet.
Not yet. Okay. Let's try it again. Okay. So. Okay.
That's good.
You see it?
Yes.
Okay. Yes, I hope you don't hit me because I had to do some troubleshooting today on an exhibition in Frankfurt, and my original PowerPoint presentation stays in the office, so I had 30 minutes to recreate it. It's not the same like the original one, but I hope it will fit. We do some event stuffs, and in this case, we build event modules, mostly for playing childs and something like that. And in this case, we like the Raspberry Pi because it's very handy and small and easy to get. So we produce many event modules with the Raspberry as a brain. But we built it completely from ground up. So we do metal, woodwork, electronics, and so on. And we do the software with Xojo. So we go the way up from having an idea to building the complete system. One of these systems is the juice bike we talk about today. This is mostly for something like fitness studios and so on. They can rent it from us, and then they get this juice bike. So the guests can ride on the bike and see on a display which speed they have at the moment and which distance they already made. And after a small amount of time, a juicer starts to make some orange juice. So they get a little present when they are ready. It's mostly for marketing and so on. Here we can see it. It's in a supermarket. We have the bike in the front and someone sitting on it. And here it's very small, but here you can see your speed and so on. And I hope that works. We have a video of it. Okay, the sound is not very important. So you have a countdown and then it starts. Okay, it doesn't start. We start again. now he's driving, and after a defined way, the machine here starting with making the juice. Perhaps we don't have a glass or something like that. I couldn't see it. No, it's too small. Okay. Yeah, it's running. You can see it here. Yeah, and he gets his fresh orange juice. It's really fresh orange juice. And it's made from really fresh oranges that we bought on the same day. How do we do that? We have a sensor that notices every rotation of the bike's wheel and calculates speed and distance. This all is done hardwired. There's no Bluetooth or Wi-Fi or something like that. It's all hardwired to the Raspberry Pi. You can set the distance that is needed to get a complete glass of orange juice. And we have the speed of the juicer that is controlled with a frequency converter. So if you are slower, then the machine runs slower. But it's powered by normal electricity. It's not from the bike. So what are the challenges we have all the time when working with the Raspberry Pi and with these electronics? The most important thing for nearly everyone who wants to do some electronic hardwiring to the Raspberry is common mode interference. If you have a switching power supply, you will get a big problem with voltage between the earth and ground. So in this case, you have to connect the ground from the power supply to the earth. Otherwise, you could get 90 or hundreds of volts, and this will damage the Raspberry Pi immediately if you touch it. This is one very important thing if you play with it, because if you put your power supply in it, you could damage it within seconds, and then you think it was broken, but you only had this voltage that disturbs it. And the next big problem in this case is the frequency converter, because you have induction in this case. So you have high frequencies, and you get many problems even in small wires on the Raspberry Pi. You will have buttons firing all the time and something like that. So it's very important to have a very good shielding for all these components. Otherwise, your software will go absolutely crazy, and you don't know why. So what can you do with this juice bike? This is more marketing. We have the ability in software to make a registration. So we get some addresses for marketing purposes or something like that. You can do a competition with a leaderboard to show who is the best driver of the day or something like that. You can do branding on the monitor, so with a logo or something like that. And you have a data storage, so you can see what you did all the day with the juice bike. Yeah, so I'm ready. That was it. We have no code. Just a little overview about what we are doing.
All right, thank you, Marius. That was really good for having to throw that together at the last minute.
So,
all right. And now we've reached our Q&A portion of the event. So assuming I can bring up the Q&A window while I have a slide on the screen, we will see what we can do here. There we go. All right, so I think Tim had to pop off. He had told me earlier he had something he had to get to before the end of this, so he might have popped off. But if you have questions that were specific to something Tim talked about, you can still ask them. At the very least, I can get those to him so that he can get back to you. Let's see, I've got comment from Justin, who also has a later comment indicating he had to pop off, that just said all of these were really awesome. Thank you, everyone. So yes, thank you very much. These were some really cool presentations that definitely showed off hardware sensors and things that, maybe as software developers, we don't always spend a lot of time thinking about. Not a question, but Edwin suggests that we should have a Xojo team painting done in that the style that the Roybot is able to do. That would be something. And let's see here. Edwin is also mentioning, this is directed at Bruno. He suggests, and maybe you looked at this, a way to sync time that could be done using a GPS module. Bruno, is that something you considered?
No, I have not considered that. But yeah, that could be interesting. Yeah.
Yeah, I mean, how well does GPS tend to work indoors? Is that a...
Yeah, well, that would be a consideration, that's for sure. The Pis are installed like pretty much in all different kind of situations. We have like close to 1,000 installed, so everywhere, from basements to kitchens to everywhere.
I don't think that would be an issue indoors. I mean, cell phones have GPS in them, they work indoors. And the one place, even when your phone's in airplane mode on an airplane, the one thing that still works is GPS. If you've ever brought up the Maps app on your phone on an airplane, you see the maps are just flying by because it knows where you are on the planet.
All right.
Cool.
Well, there you go. That's a future task for Bruno to report back on. All right, we got a comment here from Wes, who just says, excellent info. He is very happy to know about the watchdog and the graceful shutdown. And Wes, I believe, is the fellow who has made some Pi-related thing that runs in a Camaro or a Corvette or something, if I recall, the last time I think I chatted with him. So he has some experience with some Pi stuff. And let's see.
I was going to mention one other thing that I didn't say in my video. Yeah, this is Michael. I don't know if you guys noticed that, but when I do the I run the app remotely onto the Pi. And so in order to do that, I sudo the debugger on the Pi, and launch that from a terminal instead of launching it by double clicking on that. One of the other things that does is that allows you to see the comments. So when you do, when you echo something out to the console,
right?
When it's running on the Pi, you wouldn't be able to normally see those comments that you're putting out. But when you do that, when you run that from the command line, then you can see those echo on the command line. So
Yes,
does that
that's
make
always a
sense?
good tip in general when you're on Linux-based machines, is you can start stuff like that from the terminal and then get the log output right there in the terminal window. Very
Yeah, the
handy.
log output, right?
Yep, very handy. Edwin also has a comment that says it's directed to you, Michael. I'm not sure I understand it, but it says, I have heard about stronger readers. Maybe they exist.
Yeah, well, he was saying that, and I answered his question, was that RFID readers there's an RFID tag in the dog. So on the dog door, when the dog walks through there, can it read that tag that's in the dog? And it can't. And that mainly because there's the avid tags or that you put in a pet so that they can identify the pet with a RFID.
Right.
And that RFID reader has to be right up against the skin in order to read that, at least in my pet. So I was hoping that would work, but that was not going to be working. So that's why he was saying that they're stronger readers. And I mean, I know that's not even a Pi project, but the RFID antenna was around the dog door so that when the dog walks through it, it would trigger it. And so yeah.
Maybe you could do like a retina scan.
Yeah, well, you could do and you could use a Pi for this and do recognition, like use some kind of an AI thing that recognizes that it's a dog. So I mean, in that case, you could let any dog in the dog door. It's just, it's a dog, open the door, right?
Or you could train it with a bunch of pictures of your dog.
Your dog, yeah, you could probably do that. A few weeks ago, what I have there's a motion sensor on the outside, there's a motion sensor on the inside, and so if it thinks the dog is inside, and then the outside motion triggers, it changes the light on the door to red to tell you that, okay, something is out there that you don't want coming in. And the other day I checked, and it was like a neighborhood cat that was just sitting there wanting to come in my dog door for some reason. So
cats are sneaky like that. Yeah, Photos on my Mac seems to recognize my dog. But now that I say that out loud, I don't think I have a lot of other people's dog pictures in my photos. So I don't know.
I think they added that recently, actually. I think that's a fairly recent thing on the Mac, is for it to recognize pets. Where not just say, show me pictures of all the dogs in my photo library, but to be able to, like they have the people, that you can say, this is my particular dog or my particular cat, that kind of thing.
Right.
You tag it and then it knows who it is. Yeah.
All right. Well, I don't see any further questions, which is probably good because we are nearing the end of our time allotment. But again, I do want to thank our special presenters